So we have here the Doppler effect, which is you have a source of noise and it's there's relative motion between the source and an observer to the source, and that means either the source or the observer could be moving, or both of them could be moving, and basically when one of them passes the other at a constant speed, when it gets closer, when the source gets closer to the observer, or the observer gets closer to the source, or both, basically the frequency of the sound wave increases, and when the relative distance increases, so they get further away, the frequency decreases in pitch, and that's basically all there is to the Doppler effect. Newton's third law of motion says for every action there is an equal and opposite reaction. So basically, if you have a boat and a man running towards the boat, and he jumps off and lands on the boat, his action will cause an opposite reaction, and that's the boat moving offshore. Um, each of these objects has their own momentum, which is the product of mass and velocity. The boat was stationary when he jumped on, so it has zero velocity and zero momentum. The man could be running at 1 meter per second, and he weighs like 75 kilograms. Um, he has a momentum of 75, and then you know since he jumps onto the boat ends up having a momentum of 75, but their combined mass is greater. So when put into the formula, you the total velocity in the end is smaller than the original. Galileo discovered gravity in the 1500s, and gravity is basically an attractive force that just pulls all objects in the universe, and basically it just pulls everything on Earth down towards the center of the Earth. And he discovered this. He went up to some tower and he dropped two cannonballs. One of them was 10 times the mass of the other one, and he found out that they both hit the ground at the same time. So that means gravity affects all objects equally, regardless of mass. And I recreated this experiment with a cat and an apple, and as you can see, they both hit the ground at the same time.